Hey guys, so we're going to talk about Dalton's law of partial pressures. So, partial pressure of a gas in a mixture of gases is the pressure which the gas would exert if it were the only gas present in the container. So, Dalton's law of partial pressure states that the total pressure in a gas mixture is the sum of the partial pressures of each individual gas. Okay, so Dalton's law of partial pressures assumes each gas in the mixture is behaving like an ideal gas, which we'll explain later on. Okay, so if you put Dalton's law into a formula, we'll get this. So our total pressure equals the partial pressures of each individual gas. Okay, so here we have an example. So the total pressure in a gas mixture is the sum of the partial pressures of each individual gas. So if we know the partial pressure of our gas A is 1 atmosphere and the partial pressure of gas B is 3 atmospheres, and we combine those, then we would actually get a total pressure of 4 atmospheres. That's it. You would just simply add your partial pressures to get your total. Okay, and then you could also do the opposite. So if you knew the total, but let's say you didn't know the pressure of gas B, well, if you know your total is 4 and gas A is 1 atmosphere, then all you would have to do is simply subtract those two values and you would get 3 atmospheres. Okay, so, oh no, I gave you all the answers already. My bad. Okay, so example number 1. So, air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What is the partial pressure of oxygen, represented as P oxygen, at 101.3 kPa if the partial pressures of nitrogen, carbon dioxide, and other gases are 79.1 kPa, 0.040 kPa, and 0.94 kPa respectively. Okay, so our equation, remember, is our total equals the partial pressures of each individual gas. So they told us that our total pressure is 101.3 kPa. Okay, this is going to be nitrogen, carbon dioxide, and other gases, and we're trying to figure out how much oxygen is. So since this is just simply addition, we would basically add all this up, subtract it from our total. So 101.3 minus 80.08 kPa is 21.22 kPa. Okay, now significant figures. Now some of you might be asking, why is your answer in 3 significant figures when the least number of significant figures we have is 2. This is 2 significant figures. This is also 2 significant figures. If you remember way back when we first started learning about significant figures, when you multiply and divide, you are going by the least number of significant figures. But when you're adding or subtracting, you are actually going by the least number of decimal places. So if we're going by the least number of decimal places, this one right here is going to have the least number of decimal places with 1. Okay, so it would actually round to 21.2. Okay, now on your test, I will try not to trick you with significant figures and decimal places. Since we do a lot of multiplication and division, I would rather just stick with that rule, okay, not to confuse any of you. But formally, the correct answer should be 21.2. Okay, so, oh no, go back. Okay, if you want to go ahead and do number 2 on your own, go ahead and pause the video, but if not, let's go ahead and move to the next slide. Okay, so example number 2. A mixture of gases contains oxygen, nitrogen, and helium. The partial pressure of oxygen is 2.1 atmosphere. The partial pressure of nitrogen is 0.21 atmosphere, and the partial pressure of helium is 7.80 atmosphere. And the question is determine the total pressure of this mixture. So the good thing about Dalton's law is that it's just simply addition. So if we're looking for the total pressure, we would just simply add those values up. So we would get 10.11, and then again, since we're adding, the least number of decimal places is going to be 0.1 with one decimal place. So our final answer is going to round to 10.1 ATM. Okay, so that's it. That's Dalton's law. If you guys have any questions or need clarifications, feel free to comment or ask me in class. Y'all have a good one.